Here we go with chapter 10. Now we're going to move from one population to two. So either two proportions or two sample t-interval t-test. So back to the formula sheet. If I'm dealing with two means, that's the statistic, and that's going to be the standard error of the statistic. So that's where this is coming from. It's going to be a t-value. The degrees of freedom are the smaller of the two sample sizes minus 1. Confidence interval, there's the statistic for two populations, the difference between the sample proportions, and then there's the standard error formula. And then I'll have a critical z-value. Test statistic, very similar here for two sample t-test. The statistic minus the null difference, which in most cases is 0, divided by the standard error. For the two proportion z-test, there is something different here. And it's very important that you understand on the formula sheet, the only time you ever use this formula is for a two proportion z-test. And the reason is we're assuming the two proportions are equal. So I'm going to go through how to get this combined value in a few minutes. So here, it's going to be the same statistic minus the null, which typically will be 0, divided by this combined percentage. So if we take a look at this example, 15 out of 30 females got a 5, 15 out of 40 males got a 5. So the sample proportions for the males and females, I can calculate those. If we do a confidence interval, it's the difference in the proportions. I chose to do female minus male, plus or minus your critical value, times the standard error. Just plugging in, and then that's going to result in this confidence interval. Now, I'm going to go two different ways with this last question. Does the sample provide statistically significant evidence that the proportion of 5s is different for females? So at this point, I could just use my confidence interval to answer that question. No difference would be 0s included in the interval, and it is. So no, since 0 is included in the 95% confidence interval, list the specific interval, there'd be no evidence of a difference in blah, blah, blah context. If I was doing the full-blown test here, the null would be the true proportion for females minus the true proportion for males is 0. And the alternative would be, is there evidence of a difference? So it could be greater than or less than. So it's a two-tailed test. I didn't check the conditions. I'm just trying to streamline this. So the conditions met, assuming they are, we're going to do a two proportion z test. So here I get into how to do that combined piece for this formula. You take the number of successes in each group, so 15 males and 15 females, divided by the sample size, 30 females, 40 males, and calculate that, 43%. So overall, 43% of the sample received a 5. And that's going to be what I'm going to use in my denominator for this combined estimate. That's going to be the difference in the sample proportions minus the mean, the null difference. We're saying there is no difference. Gives you your test statistic, and if I use normal CDF from 1.05 to infinity, that's going to give me my p-value. So I'd end up failing to reject the null because the p-value is greater than 0.05. Which is the same conclusion we would reach here. So chapter 10 is about two proportion z intervals and tests, two samples t intervals and tests.